On these graphs, you'll see numbers next to the edges, one number per edge. These numbers are called weights. It's the cost of something. If we're putting in new roads in the city, it could be the cost of putting in that new road. Maybe it's the time that it takes you to travel from place to place with your errands. I'm going to draw a little graph and put numbers next to the edges. I'll draw a complete graph. I'll use numbers, or letters rather, toward the end of the alphabet. U, V, W, X, Y. And so I'll just make up some weights. U to V is 5. V to W is 10. X to W is 2. Y to X, 3. I'll put U to Y is 4. I got to get some for the middle ones as well. I can repeat numbers. U to W is 3. U to X, I'll put 12. V to Y is 5. V to X is 7. And I need one more. Y to W is 6. So that would be a weighted graph. Think of the weights as representing a distance. Maybe it's time, maybe it is miles. But we would like to find a Hamilton circuit that has the smallest total weight for the whole circuit. Now that problem I've just described is also one that the only way to do what I described is to find every circuit. This has 5 vertices. So there's 24 circuits. Write out all 24, add up the weights, and then say which one's smallest. That would be called brute force. So I want to write some of that. Let's put this where you can still see it up there. So we are interested in finding a Hamilton circuit where the total cost, I call it cost, the distance cost, where the total cost is a good value. I'm thinking sometimes you're shopping around for something and you want the best value, but sometimes you have to settle for a good value and it might not be the very best. The only way to know which Hamilton circuit is the very best is to find all of them, add up the cost of each one, and then say which one's the smallest. That would be called the brute force method. We do have another method. It's called nearest neighbor. We use the nearest neighbor method. to find a Hamilton circuit that gives a good value. Maybe not the best, but it's good enough. I'll show you nearest neighbor with the picture I have drawn on the previous page. Let's do nearest neighbor. With the graph above. They're going to tell you what to start with. I'm going to start at W. Starting at W. So here's the graph. And as I look at the W, from W, I could go to V, that's 10. I could go to U, that is 3. Y is 6. X is 2. Oh, we'll go to X. From X, I look at the ones that are still left. I could go to Y, that's 3. I could go to U, that's 12. Or I could go to V, that's going to cost 7. Well, we're going to go to Y. From here, I could go to U, that's 4, or V, that's 5. I have to go to one that I haven't visited yet. I'll go to U. At this point, my hands are tied. I have to go to V, because that's the only one left, and that's the only one I didn't visit. The only one left that I didn't visit. From V, I have to go back home. So I'm going to have to use that edge that is 10. Is this the best one? I don't know. But mathematicians have studied this and they said it's a good one. It might not be the best, but it's good. So on your computer, you would list this out. W, X, Y, U, V, W. And they're going to want you to give the cost. You have to add it all up. 2 plus 3 is 5, plus 4 is 9, 14, 24.